In this video, we're going to connect what we've been talking about with regards to equilibrium distance and potential energy to the actual states of matter. And so the three familiar states of matter are solids, liquids, and gases. And solids, kind of from our normal experience, we can say they're kind of, they hold their shape, right? That makes sense. And they have a about constant volume. And for liquids, you would say, well, they actually take the shape of their container, and that's because they can flow. Which solids cannot. But they also have about a constant volume. Right? I can't kind of compress it down any more than it already is. In gases, they will take the shape of their container like solids. But they do not have a constant volume. And that's because gas can be compressed. And you can fit a lot of gas into a small space, and you can kind of just squeeze more and more in. And if I were to draw these solids, liquids, and gases kind of with these, little circles representing the atoms or molecules, the solids would look something like this. The liquid would look something like this. And the gases would look something like this. And I'll show arrows just to show their velocities. They're kind of just zooming around. And now I'm going to connect some words about their potential energy. So I would say that solids have very negative potential energy. And we'll talk about this. Liquids have negative potential energy. And gases have zero potential energy. And what I'll say is that the distance between two atoms or molecules in a solid is generally the equilibrium distance, right? Just about. And the distance between two atoms or molecules in a liquid is like it might be slightly larger than our equilibrium, but it's close. And in gases, it's just kind of like really large distance apart. And if we remember back to our picture with equilibrium distance, and we just draw the potential energy, right? You're going to have this point where the potential energy is the most negative. We said that would be the equilibrium distance. And so if solids are usually spaced apart with the molecules at the equilibrium distance, they would be really stable. And that kind of makes sense in our conception of solids. And again, we can think about these molecules or atoms as having springs on them. Right? And if they're at the equilibrium distance, they're kind of at that kind of resting spot for the spring. But unlike liquids, solids have a crystalline structure. And that means they have this very precise way that they're all organized and connected to each other. And kind of I have this nice little cube going. But you can imagine there are actually other shapes as well. And for instance, ice has a more hexagonal shape. But I can kind of think about solids as having this kind of setup structure. And they have a crystalline structure. And that structure makes them especially stable. And we will talk about that in the next video. And liquids, I would say, are more like, they're more like these molecules. And yeah, there's definitely springs involved, but they're not attached in any particular way. They don't have a particular way that they're all kind of together. We'll talk about this in the next video.